we've probably been dealing with Powertec for a number of years. I think one of the earlier products that gained a lot of traction were the dials that are used in elevators. So in the construction phase of buildings, they'll have to have a phone dialer for safety reasons, obviously. And once the buildings were completed, then the building owner would be buying another dialer for their elevators, and that was a unique solution provided by Powertec. So we started dealing with these guys quite a while ago, and now we've got an emerging issue, I guess, in Australia regarding phone reception. Obviously, we're getting more and more dependent on our phones and our data. And so that's a massive issue. You know, in Australia, the statistic is that we've got 1 million square kilometres of coverage, and you know, that's the equivalent of South Australia. So if you looked at coverage, we can cover just one state of Australia. So, you know, in most regional areas, there's a huge issue. And so when we looked around for solutions, there's only really one solution, which is from the guys at Powertec, called Cell5. It's a very exciting product. You know, for our cell phones, you know, for our data, for our voice. More recently, Adam became our contact, our sales contact. So yeah, we've enjoyed a lot of correspondence with Adam. I think you'll find him really supporting. The fact that their guys have come down here today is representative of that. And we've got Geoff here, who's a network engineer for the guys at Powertec. He's come down from Brisbane.
Gold Coast.
Gold Coast.
Yep.
Yeah. Gold Coast. Gold Coast. Yeah. So really, as far as questions go, you know, try to imagine yourself in these situations where someone's from a regional property, they may be getting no signal, maybe one bar, and these people are desperate for a solution. So. Having Geoff's contact details is fantastic. I didn't ask you in the last session, your presentation, are we allowed a copy of that? Am I putting you on the spot here?
I'll need to check with the product development team, because it is confidential while I'm showing it to you, and you guys are actually recording it. So I can provide details through Adam, through our product guys, get him to check with the product team, and either, if not, take some of the information that they don't. This is a carrier presentation that they talk with the operators on, so we can adjust it or provide another version of it, taking out the bits that they don't want to have published. So,
right, so
yeah, we can fix something up for you.
If we can get the presentation, we'll either we'll chuck it on our company folders if we can, and if we can put it online, we'll put it online.
Yeah.
Yeah, I'll hand you across to Geoff.
Great, thanks, Mike. My name's Geoff Carroll. I'm a network engineer with Powertec. Powertec's a distributor of communication systems. Typically, we started out in 1996 providing voice gateways, so put a SIM card in a little box, connecting up a plain old telephone or a PBX and being able to make calls from a desk phone out via the mobile network. Reason for that was all you can eat for X amount of dollars. A lot of companies making a lot of outbound calls were able to make cheap calls that way. Pardon me. We've developed into a company distributing products primarily around cellular systems, so the voice gateways, which we just alluded to, mobile phone boosters, SIM-based or cellular-based routers for industrial applications, high-end carrier-grade Wi-Fi and wireless point-to-point systems, SMS gateways, a whole range of products around typically cellular-based setup. My role in the company is product development, higher level of support and design with working with our resellers. We're a distributor of the products. We do a little bit of retail to end users, whereas they can buy some of these products online, but most of it is through our distribution channel. We have, up until recently, we had about 3,000 resellers across Australia. We're reducing the amount and concentrating the number of resellers that we have. Today we're going to talk about the mobile phone signal boosters. Mike alluded to again that a common problem now in regional areas, even in suburban areas and city areas. Signal is a problem. People's life depends on, and lifestyle and business depends more and more on connection now, or connectivity to the outside world via internet, and then also the ability to make and receive calls. As the building standards change towards more green sort of applications, you know, lots of insulation, tinting, different level of building products, it's becoming more and more difficult to get a signal from the outside in, hence the requirement for signal boosters is increasing in demand. The carriers or the operators use them for customer retention. You know, coming along and they're paying a monthly amount, and sometimes it's an exorbitant amount, you know, $100 a month or more to have a phone plan. Yet in a lot of places, even at home, they're not able to use the phone because there's no signal inside. So that's where these products come along. In this presentation, we're going to talk about Cellfi, which is a product made by an American company out of San Diego called Nextivity. They supply these products to over 200 mobile phone operators around the world, and we have approval for these products via Telstra, Vodafone, Optus, and Spark, 2 Degrees and Vodafone NZ. So we distribute to them. Digicel in the Pacific, we ship to Malta. Singapore, we've got a number of locations where we legally supply these devices. Jordan, is it? Jordan raised the question earlier about the legality of these products. These Cellfi products are the only legal boosters in Australia, so nothing else is legal. So that means it goes through a process of certification by ACMA, and then the products go off to certification by the operator or carrier to ensure that they're suitable and operating within their guidelines of their network, so there's no interference and no problem. Powertec used to be part of the problem. We supplied mobile phone signal boosters for the last 10 years and were part of the problem. Typically the old boosters were an amplifier, so they'd have an input antenna, an output antenna, and it's just boosting full blast all the time, which creates, in simple terms, a tromboning effect. You know, you've got a microphone and a speaker and they start howling and, you know, it just keeps over amplifying itself. That's what was happening on the mobile phone network. So what that does then is it takes certain capacity out of the Telstra's or the carrier's cell network, and then can even shut the cell down and stop people from making calls and, you know, in life-threatening situations, being able to not being able to dial 000. So ACMA and the carriers are on the hunt for illegal boosters. They will, once they find them, they will give the user a show due cause. If they fail to shut it off, they can be fined 250 grand. So it's a big deal. It can cause problems. As I mentioned, life-threatening situations is a problem. Don't be afraid to ask any questions during the presentation. There's no silly questions. You can quite often people are having the same question, and we can address it as we go. What we're looking at here is a Cellfi. What it's doing is it's basically providing mobile phone coverage in buildings and in areas, vehicles, outdoors, indoors, in areas where the mobile phone signal is difficult. Sometimes that can be due to construction, location, lay of the land, etc., or even being in a regional environment, especially being out of range of the mobile phone signal towers. The devices don't require a SIM card, so they're basically grabbing the mobile phone signal, reboosting that, and then broadcasting it back out. So I can't say Adam's phone can connect, Mike's can't, Geoff's can. It's basically rebroadcasting out a mobile phone signal as it would being broadcasted from the tower. They don't require an internet connection, so it's basically taking the mobile phone signal from outside or from a long distance away, grabbing that signal and rebroadcasting it out. Some of them are plug and play, others require installation, and we cover all the operators in Australia, New Zealand, the Pacific, etc. These things are the only legal boosters in Australia, so everything else, if it doesn't have a Cellfi logo on it, is illegal. They need to go through a very extensive certification process, firstly with ACMA to make sure it fits within the guidelines of what frequencies it's going to operate or work in, and then to the mobile phone carriers using their identifications of their network to be able to work. So the Cellfi itself, while they look the same, for the different carriers has different hardware and configuration inside them. So one that's suitable for Optus won't work on the Telstra network and vice versa. So they're an independent box, got a little bit of different chipset inside them, and can't be changed. They can't be reconfigured to work on the other networks. It's unconditionally network safe because of the technology it uses. And we were talking about before, that tromboning effect over amplification. These things continually monitor the input and output, so the two antennas, if you like, and make sure that they can't see each other and start to create this tromboning or circulation effect. It's an on-chip system, which is quite expensive to develop. It's patented. It's been a long time in development, and hence the hardware isn't cheap. So the cost of certification and approval, the cost of the technology and the development in the technology makes these things not a cheap item. So you know, you can't go and buy one for $100 there, like you could with the illegal boosters. And it's approved by carriers everywhere. As I said, some of them are plug and play, others aren't. There's not many options when it comes to boosting mobile phone signal. You've either got what we have here, or an expensive, what we call a distributed antenna system, which is a license-based thing that a carrier would come and deploy. It's got a lot of hardware antennas strategically located around. You know, you're looking at minimum $350,000 to deploy a DAS, or a distributed antenna system. So the only options then are the products that we're going to look at now. The benefits to the mobile phone operators are obviously new customers. You know, the customer goes and buys a plan, they spend $100 a month, but they can't use it in the house, so sometimes the carrier will say, here, take that, and set it up, plug and play, and away they go. It can keep with customer retention, so if I had signal before, yet I've moved to another place and now I don't have mobile phone signal. And it's a cheap way of the customers to extend their, of the carriers, sorry, to extend their network. And it can provide temporary coverage in areas for events or functions where mobile phone signal's a problem. We've got a lot of people joining in to a particular function or event. The range of the models that we have, and I'll go over and explain in a little bit more detail. We have, what we talk about here is the bands, so the bands that the product will work on. These are the frequencies that it works on, so we have a 4GX, 3G, and 4G for Telstra. We have 3G, 4G, and some of the other 3G and 4G bands for Optus and Vodafone. These boxes here we call the Selfie Pro. They'll boost 3G and 4G at the same time. And they're basically a plug and play item. So you take them out of the box, plug them into the power points, and they'll set themselves up and are ready to go in a few minutes. They're made up of what we call a window or network unit and a coverage unit. So the window or network unit typically grabs the signal from the carrier. So we'd take that box, set it up near a window. Window's typically got signal in it. If any place in the building or house has got signal, the windows generally do. And we can determine that by going around the house using the phone to determine whether we've got some signal that we can use. Then we go and locate this coverage unit somewhere in the centre of the house or the centre of the area where we want coverage, and the two communicate with each other, set themselves up, and away they go. If there's no signal at the window, it has an external antenna connection on it, which we can then connect up a series of external antennas, again depending on distance from the telephone tower or direction that we're getting the signal from, the level of gain we need, etc., determines the type of external antenna we would require. The two boxes communicate with each other via two wireless links, so they have an uplink and a downlink, and is operating what's called the unlicensed 5 GHz spectrum. So it's an unlicensed free-for-all, things like Wi-Fi, point-to-point data links, baby monitors, Panasonic Uniden cordless phones, they all operate in this 5 GHz spectrum. And it's only a small amount of airspace, and these things can cause interference in the communication between the two boxes. So typically these things we'd use in a residential environment and maybe a small business, but once you get into an area where there's a lot of 5 GHz noise and hospitals, universities, schools, businesses, not really suitable because it takes down the link between the two boxes. New product we're waiting on approval is based on the same principle, so we've got a network unit and a coverage unit. So the coverage unit is providing the signal to the end device, whereas the network unit is grabbing the signal from the carrier. And the signal bubble, if you like, can't be greater than the distance between the two boxes. So we've got a box here, a box there. The signal bubble coming out of the coverage unit can't be greater than the distance between the two boxes. This one here then incorporates a network unit and then a number of coverage units, up to 4 can be connected to via cable. And these can then be stacked on top of each other to provide a multi-storey in-building solution, providing access to a massive area. These things. Pardon?
What cable is it?
Cable? Yeah, so Jordan's asking what cable can be used. So it's running on typical building cabling, Cat5e, Cat6, whatever. It's using a proprietary signalling protocol, which prevents intrusion or deciphering and people being able to listen into the comms. The distance between there and the coverage units is up to 250 metres via a proprietary PoE and signalling protocol. And these can be deployed throughout a building, either on the ceiling, on a wall. They have external antenna ports to provide more directional antenna, beam widths, etc. Again, we have a Telstra and an Optus Vodafone one in the final stages of approval now. We move on to probably the products that you guys more than likely play with is these Selfie Go's. There's 4 versions of it. These 2 are still in approval process with Vodafone and Optus, whereas the Telstra models are readily available now. They boost all of the bands, so 4GX, 3G and 4G, whereas these devices will boost 3G and 4G at the same time. The Selfie Go, the Telstra one, will boost one or the other. So it'll either boost 3G or 4G, and the differences we'll talk about in a minute. The difference between the 2 boxes here, we've got a stationary model and a mobile model. One, as it alludes to, is for a stationary environment, either a small building or a larger building, something that's not moving, whereas the mobile version is designed for cars, boats, trucks, buses, tractors, whatever. The main difference between the 2 is the level of boost or gain that it will give, and the ability of the mobile one to quickly switch between towers. And then also what it does is, in simple terms, if you've got about 2 bars of reception on your mobile phone, it'll stop boosting. So that stops it then, when you come into range of the tower, let's say, it'll stop boosting until you pass by the tower, and then at a certain level it starts boosting again, and that's what makes these things legal. It'll hand over between towers at up to 120 kilometres an hour, similarly to your mobile phone, whereas the stationary version takes about 2 minutes. So, Selfie Go M and the Go X, these boost 3G and 4G at the same time, and are designed for Vodafone and Optus, and they have an IP rating, which means they can be installed outdoors. Splash, dust and shock resistant. Whereas these guys, you can basically plug and play with those. These require an installation, so they require what we call a donor antenna, getting the signal from the tower, and a server antenna, which is providing signal to the devices. Selfie Pro, just a basic example of what these are. We talked about it before, a network unit, which is grabbing the signal from the tower outside, communicating via an uplink and downlink in the 5 gigahertz to the coverage unit, which is then putting out a signal bubble to provide coverage, in that location. For indoor applications only, set up, easily within a few minutes. So you plug them in. This one looks at the tower, says, "Yeah, I'm a Telstra box. There's a Telstra signal. I've got that. I can see him. I'm talking to him. Bang, there it goes, and you'll see instant signal boosting on your phone." As the statement says there, the signal bubble or the output signal can't be greater than the distance between the 2 boxes. Okay. A bit of the specifications on the things. So we've got a Telstra and Vodafone version, or Telstra Optus Vodafone version. You can see the different bands that they're supported, which means there's different chipsets and hardware inside the boxes. A whole range of international models as well. Suitable for voice and data, so increasing the ability to make and receive calls on 3G and 4G. High level of gain. Main difference I want to make you aware of here is on the data side. If you're directly connected to the tower, the speed that you get, like if you're doing a speed test or something like that from a data connection or internet connection, will be greater than it would if you're connecting via the Selfie. The reason for that is the channel width, if you like, between the 2 boxes. So if you're directly connected to the tower outside, you might get a high data rate. Once you connect to the Selfie, even though we're connected to the same tower, the data rate will be much lower. And that's because of the channel width between the 2 boxes here, and trying to maintain communication in noisy environments, in this 5 gigahertz spectrum. They operate on 12 volts, have a relatively high operating temperature range, and can provide up to 1,200 square metres, which 1,200 square metres, 30 metres by 40 metres, so it's not that big. Okay, typical house, small business, that type of thing. And the external antenna port is an SMA connection. All the devices have Bluetooth connectivity into them, which means we can use a proprietary app to set the thing up and check the health of it and make sure it's working at its optimum. We'll have a look at that as well. Just an example here, you know, a typical small business, grocery store or something like that. Front of the building near the checkouts, we've got a bit of signal there. Down the back, there's nothing. So you can't use your mobile phone for calls, SMS, check recipes, all that sort of stuff. A solution in this example is to put a Self-I Pro in, you know, the window or network unit where there is the signal, and then, you know, the distance between the two boxes can be a maximum of 80 metres in a line of sight environment, up to the coverage unit, and it's providing us with a good signal throughout that location. One of the problems that we see in the city areas is, you know, a lot of reflected signal, and even in the streets in some locations there's no signal. So, you know, tinting on the windows. What we find in tall high-rise buildings as well is once you get up above level 40, anything above that level there's no signal because all the antennas from the carriers and the mobile phone towers are pointing down towards the population in the streets and the buildings. So once you get up into the higher levels of these high-rise towers, there's no mobile phone signal. Same sort of thing here, getting some signal from the outside near a window or a location in the building, the coverage unit in the centre of the building, or it could have been further up here if need be, and it's providing access to all the users in there. The devices aren't limited to the number of people who can be using them. That comes from the mobile phone tower. So depending on the type of equipment that's at the mobile phone tower, the size of the cell and the licenses, etc., determines how many people can be using these devices simultaneously. A typical cell is between 50, so a typical, you know, those long skinny antennas on the mobile phone towers, typical capacity of one of those is between 50 and 250 users simultaneously. An example in a home environment, you know, even in suburbia, the lay of the land can stop the flow of mobile phone signal. You know, we've got a tower over the hill here, and what we find is in the bowl or in the lay of the land, nobody here's got mobile phone signal. Solution again, network unit in a location of the house where there is some signal, or we put an external antenna on top, can be high on a mast and pointed in a direction to grab the signal from up to 100 kilometres away depending on the type of antenna we use. Coverage unit in the lower floors here, and it's providing coverage all throughout the house and for all users. It's worthwhile explaining at this point the difference between your signal readings on a mobile phone. So 3G, you know, the number of bars that you receive on your mobile phone signal, 3G is all about the signal strength, so the strength of the signal, pardon me, which in a 3G environment, the more signal you've got is a better call quality and a better data quality as well then. Whereas 4G not only talks about the signal strength but also the network capacity. So you could be very close to the tower but still be only getting 2 bars, and that's because it's not just taking into account you've got a great signal, the tower can be overloaded, and therefore we've only got, you know, a small data capacity, and that's reflected in the signal bars received. So when we plug this in, the customer says, oh gee, I'm not seeing any improvement in my signal bars. Well, we're not going to do that on 4G, but if you switch your phone to 3G you'll see 5 bars straight away. So that gives you a good indication of what's going on. The majority of mobile phones still in Australia will make calls over the 3G network. So in the event that you make or receive a call, your phone switches to 3G, and at the end of the call it'll switch back to the 4G for your data. So it's worthwhile in some of the devices here where we can set them to boost 3G or 4G. We understand what the customer's devices are, what they're using it for, whether it's going to be for data or whether it's going to be for improving mobile phone signal for phone calls. The Self-I Go then is suitable for indoor and outdoor applications. It will boost 3G and 4G or 3G or 4G with the current Telstra model. It's switchable via a button there, or you can do it through the Bluetooth app to set it to either or. You can leave it in automatic mode where it'll boost whatever it's got a best signal for. These things aren't plug and play, they require installation. A couple of SMA connectors on each end, requires a donor antenna, so grabbing the signal from the carrier, and then a server antenna or a series of server antennas to provide coverage for the devices in or outdoors. we can combine, we can put a signal combiner or splitter on the server side and connect multiple antennas onto that to provide large coverage indoors and outdoors. And with the all-in-one box here, we don't have any requirement, or we don't have the 5 gigahertz links, and therefore we don't have the interference on the link between the two boxes as we would with the Selfie Pros. Schools, hospitals, that type of thing are just flooded with 5 gigahertz. Even most businesses now are using 5 gigahertz Wi-Fi, massive channels, and it stops the standard residential boxes that the Selfie Pros for working properly. So the Selfie Pro, as opposed to these ones, is more suitable for a residential or small business, whereas these are more of an industrial option. And depending on the type of antennas we use, whether we're using sector antennas or directional antennas, omni antennas, determines the coverage that we can get indoors and outdoors. 4 models for these. So currently these are the only ones that are approved, which is for Telstra. So do 4GX, 3G and 4G. The Selfie stationary model is suitable for small buildings, small houses, portable buildings, car parks, areas where there's no mobile phone signal. A high level of gain for the stationary model, a bit lower for the mobile version of it. 12 volt DC, so suitable for, we'll see some of the applications in a minute, but suitable for an in-building sort of solution where it's not moving, and suitable for car, boat, truck, tractor, train, etc. These models there are for Vodafone and Optus, so they're supporting the Vodafone and Optus bands, and will boost both at the same time. Going to have a stationary version and a mobile version. The only difference between the stationary and mobile is its ability to switch between towers quickly. In building application, we've got an external antenna, typically grabbing the signal from outside. Depending if there's plenty of signal outside but nothing inside, you can use a little omni antenna. If we've got to drag the signal from a long distance, it's beneficial to use a Yagi or a long periodic antenna, depending on the bands that we want to bring in. Connects into the Selfie Go and then into a server antenna, whether it be a panel antenna or a dome antenna, depending on the type of output signal we want to provide there. Same thing if we want to provide outdoor coverage, again antenna on the roof, coming down to the Selfie Go, and then an external sector antenna which is broadcasting the signal outdoors to machinery sheds or garden, farm, aprons for transportation, wherever. In a lot of instances between these big metal sheds that are being built for warehousing, etc., there's no mobile phone signal between the buildings, so pushing it out for in between buildings is a common requirement as well. Or using a combination of both, so having a combiner on this end, having an internal dome to provide coverage here, and an external antenna there to push the signal outside. Even using a small one of our sector antennas, depending on the level of boost. So again, we were talking about before, we've got the 2 boxes. The signal bubble between the 2 is determined by the distance between the boxes. Same thing here. So the output signal from this determines the ability for these 2 not to see each other. So there's some, when you're doing the installation, we'd obviously put this cable in permanently, and before we confirm the location of this antenna, using the wave application to determine the level of boost to make sure that we're getting this antenna separation to get the thing performing to its optimum. We install, or our resellers install these in cars, boats, trucks, buses, emergency services vehicles. A typical application is in a 4-wheel drive, travelling, on the grey nomads or in the agricultural sector. External antenna on the bull bar typically. Selfie Go under the seat, and to get the separation we'd put the server antenna on the firewall of the car, so it's got a metallic separation, so we're tricking the antennas into thinking that they're much further apart. A typical installation there would provide us with signal within the car there, and maybe a metre or 2 outside with the doors or windows open. Same in the emergency services or fire trucks, etc. We have to be careful what the truck or the cab's made out of. A lot of them are made out of fiberglass, so getting this antenna separation is difficult because the RF or the signal will penetrate through the fiberglass. So antenna separation is critical to the thing working properly, and that's the same with RV and caravans and that type of thing. What we look for there is in an environment where it's using a fiberglass cabin or space, we'd look for something like a metallic bridge to provide that separation for us to make these things work at optimum. Same on a boat, antenna up on the fly bridge, run the cable out temporarily until we get the highest level of boost and providing the signal bubble that we want. Trains, caravans, portable buildings, dongers, mine sites, that type of thing. Very difficult to get the signal outside here. These are like a Faraday cage, if you like, and a Selfie Pro, one of the two box solutions won't work in this environment because it's just too much signal flying around inside, not enough separation between the boxes, whereas the Selfie Go external antenna, internal antenna will fill the portable building or portable buildings full of signal. Multi-room or multi-tenanted applications, so big warehouse with cool rooms, that type of thing inside them, or a lot of separation, or even being able to just isolated business or office setups. So external antenna, Selfie Go, splitter combiner, and then into multiple indoor antennas. So we're starting to provide a huge coverage signal. Multi-level car parks. An example of some of the applications that we've done. This is a caravan park up at Exmouth where you go snorkeling with the whale sharks. This whole area becomes full of life in wintertime. Summertime it's too hot, but wintertime grey nomads and people travelling around Australia visit this particular location. While these cabins up on top of the hill here have mobile phone signal to the tower, which is about 30 k's away, everything down in the little bit of a valley there has no signal. So anybody who wants to make or receive a call, contact relatives, Facebook, etc., has to drive up to the top of the hill to get mobile phone signal. Here's a side profile of it. So the cabin's up on top of the hill, the tower's down this way 30 k's, everything down in here, around here has no mobile phone signal. The solution we design, Yagi antennas coming into a splitter combiner, a Selfie Go boosting 3G, one boosting 4G, and then connecting them back into a dual pole antenna to put out the 3G and 4G signal in that signal beam width. So pushing 3G and 4G out there, and we're getting full mobile phone coverage right throughout the whole property now and over onto the sand hills and beach, about 650 metres in distance. Happy holiday makers, happy people. Another typical application that we do, and another problem throughout regional Australia, is mobile phone signal up on top of the hills. Down on the water plain where the homesteads and farms are, there's nothing. So what we do is we put a mobile phone signal booster up here, one of the Selfies, with a solar pack on it, so it's operating on solar. An antenna grabbing the signal from the tower, and antennas pushing the signal down to the farmhouse there. We can get access down here then as well, and then more repeaters down here, more Selfies grabbing the signal from this one and then reboosting it down that location there. A combination of indoor and outdoor antennas, so indoor ceiling domes, and then external antennas pushing the signal out to the other cottages, and there's the panel there pushing the signal out to the cottage and the dining areas. Happy dog. Antennas. Some of you may be familiar with antennas. We design, and we don't manufacture them here, but we design all our own antennas, and they're approved for use on the Selfie devices. All the Selfie Go's must be installed with one of our antennas. The reason for that is a lot of people have existing stuff that's in play, whether it's on a four-wheel drive or an existing antenna that, I don't need to replace when I've got one. It might not be tuned for the frequencies that we need to use, and therefore when it comes to troubleshooting, we don't know. We don't know what's on the other end. We don't know what it is. We can't test it, that type of thing. So in order to provide the level of support that we do, it must be installed with one of our antennas, or a new antenna in the case of the pros. But the Selfie Go's must be using one of our the antennas that we supply. Main difference between the antennas obviously is the frequencies for which they are tuned for. Typically a Yagi type of antenna where the elements are roughly all the same size, a little bit of difference in the separation, has a narrower band of frequencies that it's tuned for. Whereas the log periodic, we've got low frequency elements going through to the high frequency, so it covers a broader spectrum. So this is very narrow, whereas this is a very large spectrum that they cover. All the Omni antennas are suitable for the higher frequency. So if we're looking at boosting 4GX and 3G only, then a Yagi is suitable. If we need to boost the 4GX, 3G and the higher frequency 4Gs, then log periodics or Omnis are more suitable for that as well. When we look at the gain, gain refers to dBi, I being what we call a perfect isotropic radiator, which has zero gain and zero loss, so it's a perfect antenna. When we talk about gain, we talk about higher levels of compared to a perfect radiator. You'll see there's variations in the gain across the board, and that's because gain isn't flat, so it's not linear. At different frequencies, the gain goes up and down, so hence the level of gain adjusts accordingly. Beam width, so obviously an Omni antenna is looking from the top of it, providing 360 degrees. The higher gain has a narrower vertical beam width, so a lower gain antenna, while it's shorter, will have a wider vertical beam width, while a higher gain will be more narrow. So a higher gain Omni isn't always better. It depends on the environment that you're in, whether it's a hilly environment, you've got cell towers up on a hill, a lower gain antenna might be more suitable because it has a greater vertical beam width, whereas a higher gain is probably best used in plains and flat lands, if you like. Obviously, once we start using directional antennas, the beam width reduces, 30 degrees for the vertical and horizontal beam widths or azimuth, which we can then grab the signal from longer distances and with less interference. We have a full range of marine antennas, etc. Ones for bull bars and trucks and buses and that type of thing, different levels of gain. The server antennas for the Self-Eye goes, as we said before, so we've got a donor antenna, which are the Omnis and Yagi type things, and then we've got the server antenna, which is delivering the signal to the devices, a whole range of antennas for those. You can use the Yagis and LPDAs to push the server antenna signal a long way as well. Whole range of wall-mounted antennas, ceiling dome antennas, more flash, for higher end houses, hotels, and areas where they don't want to see an ugly looking dome poking out, and a whole range of antennas for outdoor use as well. Typically, an antenna that you'd use in a car or a bus is something like this, a little paddle pop stick antenna with adhesive back. All the server antennas are tuned right across the board for all frequencies, so we don't have to worry about the type of antenna we use, just the antenna pattern we want to put out. A new product for us, which we're about to release, is the Self-Eye Quattro. So it's a supercell system. The alternatives for this is a distributed antenna system. I think we touched on this before. Minimum cost for a DAS system is probably about 350 grand. It's a licensed thing. There's a lot of hardware and installation and configuration and testing with it. Whereas this is a plug-and-play small cell application, operating in the same sort of way in which our Self-Eye products do. So it has a network unit or coverage unit, and then up to a network unit or a window unit, and up to 4 coverage units connected to the network unit via the building cabling infrastructure. And then we can stack these network units together in order to provide a massive coverage area. One for Telstra, one for Optus. And these will do 3G and 4G at the same time, and they're MIMO. So whereas before we didn't get that capacity once we were off the Self-Eye product because of the channel width, these ones are MIMO, so it's basically replicating what's outside. Because we're using cable, not the frequency. Bit of a look at the boxes. Network unit's got 4 connections on it for the coverage units, just using the building cabling, LAN connectors, so Ethernet ports on it. External antenna ports on the network unit and external antenna ports on the coverage unit, so we can use an array of antennas to provide directional coverage. Just more overview of it. Again, PoE up to, well, that says 200, it's actually 250 metres, so Typically, standard PoE or Power over Ethernet standards is up to about 90 to 100 metres. This is a proprietary signalling PoE and can get us up to about 250 metres using these non-powered extenders. So these don't use power points, none of this uses power points, only that uses the mains power there. It's providing a better solution to a small cell, which is typically, you know, a centrally located thing with sector antennas. We're providing more targeted coverage using the Selfie products. Just an example, obviously these aren't approved or waiting for approval. They've been ACMA approved, just waiting for carrier approval now. So this is just an example of a Selfie Quattro installation in the US. We have about 250 units in stock and they've all waiting for installation to Telstra customers. The Wave app, so this is a free app that you download from the Play Store or iStore. It's suitable for iPhone, Android, etc. So this allows us to optimise. This allows us to optimise the performance of the Selfie. Okay, so via a Bluetooth connection, all the Selfies come with a Bluetooth capability into them. We download the app, fire it up, it communicates with the Selfie. If there's more than one Selfie, we can determine based on the serial number of that device and look at the status of it. So it tells us when we turn it on, hey, things look good or things look not so good. It tells us the signal strength from the carrier, who the carrier is, the boost level, and whether it's boosting 3G or 4G. A bit more detail there. So things look okay. This is what it shows you when it connects up to the Selfie. It can take a couple of seconds to connect, and then it comes up with the welcome screen. Things look good. It's got 4 bars of reception on Telstra 4G, and the boost is at 5, which is okay. And it'll tell you any errors there, which you can then interrogate further into the device. It gives us the ability to set what frequency it's boosting, so whether it's 3G, 4G, or we can put it in auto mode, and then we can select whether we're boosting 4GX, 4G or 3G as well. Gives a whole load more information for those that want to know about it and for when we're diagnosing issues further. Having the Wave app allows us to log in over the top of it via our global portal, and we can see the status of the Wave apps online as well, and I see the status of the Selfies online as well, and help with diagnosing any issues. Has an installation guide, so it can help you with antenna alignment, troubleshooting, gives you error codes. One of the common error codes is E8 with too much signal, or E1 no signal from the carrier. Any questions? So all of this is included or incorporated into the Wave app, and we can get you to send us a copy of the operational logs of it via this application as well. The main thing is here that when you're installing is to look at the boost. So the boost is really an indication of how much separation the 2 boxes or the 2 antennas are seeing, which refers to then the performance. So the higher the boost, the bigger signal bubble it's going to put out. A typical installation I think is around about between 5 and 9. One of the main issues we have is before a customer can buy a Selfie, they have to do an application. So they have to do an online application which records the serial number, the address, or a contactable address if it's in one of the mobile versions of where the device is located. That means that if there is a problem with the device, which can happen, could get hit by lightning, could get power surge or something like that, and stuff up its ability to monitor its output power, starts to cause problems on the tower. The carrier needs to identify where it's located at, and that's done via the registration. So we keep a whole database of every location where the things are installed. That at present still has to be done before the customer can purchase and before we ship. That's changing. We're just in the final stages of rewriting our agreement with Telstra to allow us for you guys to hold stock and either register them here before they go out, or the customer can do it within 15 minutes of turning the thing on. So it allows them to register it, it's then recorded in our system, and away they go. So when people buy these sort of things, they want them here and now, so come in, pay for it, I want it now, I don't want to wait a day or two before I can get the thing, yeah. Our Wave portal allows us to interrogate the devices remotely from our office, wherever they're located, provided the end user or you guys have got the Wave app operating. We can see where they are, how many they are, based on the serial number of the device. So when you call us up, we'd say start up the Wave app, tell us the serial number, put it in, and we can see everything that you can see and more. We do a lot of the remote applications for remote communities, Aboriginal communities, stations, that type of thing. Large poles, solar powered, and then localised coverage around here. 400 or 500 metres isn't out of the question, providing the whole thing. Lots of accessories, small battery backups, 12 volt adapters, for the cars. The devices all run on 12 volt. We supply solar if need be. Carrier configurations, don't need to worry about. Basically an overview, we've covered that. That's it, gents. Any questions?
I'll just come with the registration, just you're saying you register to the person or the address, so that person decides to sell his home and shift, decides to take that with him, he can then re-register.
Yes.
The address?
Yep.
And he must do that still?
Yes. On the Selfie webpage, there's a part to change your address. It needs to be updated.
So, but if you had to go down the track,
yep,
where it can be done,
yep,
through that, you can just re-register?
Certainly can, yeah. Re-register, a change of address, it's called, Leon. One of the other things there as well is the mobile phone version, or the mobile version of it. So even though it's travelling around Australia, it could be, in the grey nomads or in a truck or car or boat or wherever. We've still got a registration address where we can contact the owner if need be to say, hey, seems like the carrier's identified your product is causing some problems. We need to get it back and replace it, or find out what's going on. Anything else?
What happens if a Telstra customer decides to change to Optus?
They have to sell that one and buy another one. Yep.
That's good for us.
Yeah, yeah. You can sell them all day on Gumtree, eBay. There's not a problem with that. The hardware and the configuration is different inside the boxes. So with Vodafone and Optus, we can change from one to the other, but we can't change a Vodafone or Optus to a Telstra and vice versa. Different chipset, different configuration, and they don't work.
Not fully software-defined radio yet?
No, it's too much in the chipsets, bands that are supported. So we could probably do it, but it'd add probably twice the price to the product. So already it's quite expensive. It's not cheap, as you'd be aware, yeah, so that's the reason for it. And that's the reason why the Selfie Go only boosts one band at a time as well. We could certainly do it, but we've bought it at a price. So
you are able to deregister a product and resell it afterwards?
We're able to what, sorry?
Deregister the details on the product.
Deregister?
Remove all your details.
If you're selling it.
Yeah, so if you sell it, if you
sold the house and you left it in the facility, you'd get the new owner
to change of ownership. Yes, not a problem. Needs to be done. Yeah.
Because you don't want your details left there when you try to sell it.
Exactly. Yeah. Yeah. So, change of ownership or change of address is required.
What happens about mobile devices then in terms of registering on cell sites, or is that a different software base?
Sorry, I can't.
With the mobile devices, the fixed devices, you register to a particular cell site.
Yeah, no, it's registered to an address.
SSID?
No, SSID, station set identifier as Wi-Fi.
How do you detect the change of the device from one house to another?
It doesn't bother us. Optus used to do locking. They don't do it anymore.
Okay.
Yeah.
I just got the impression that you look at the tower.
No. Optus used to do locking of the device. Yeah. So then if you moved, you'd have to contact us for an unlocking process. Yeah. They don't do it anymore. But SSID is Wi-Fi. So station set identifier is a Wi-Fi broadcast name, not cellular.
Okay.
Any other questions, gents? Sorry.
You had multiple, you had, say, your neighbour had a Pro as well. So, are they just paired one-to-one?
Yeah, so question, so you're talking about you don't want to, yes. So the network unit and coverage unit both have the same serial number, and that's electronically stamped into them, so it can only talk to that one. If you start installing multiple Pros, what you need to do is ensure that the network units are separated by at least 1 metre, and the coverage units, the lines between the coverage units to its network unit don't intersect. That will cause problems. But what you'll find as well, you can't really install more than 2 or 3 pros in the same location because there's just not enough capacity in that 5 gigahertz spectrum. So yeah, we've got some of our resellers, or one of our resellers in particular, has developed a way where we require separation between the boxes for it to work. He's worked out a way in which we can sit them both together and operate at full boost through an innovation that he's developed to do that. And he deploys those in hospitals and universities and that where there's a lot of 5 gigahertz noise and interference is a huge issue. Great. Thanks very much for having us, gents. Thanks.